Okay, so a quick recap from the previous class. So basically, container are stored in two ways. You can either store in your private repository. Okay, every organization have their own private repository, or you can push it in the public repository if you want to make your product alive or make it accessible throughout the globe. And that place is known as Docker Hub. We'll look into this one. Okay. Before container, there was a lot of discrepancy between the developers and the QA or different roles. We're having multiple confusions because of the versions configuration of the application. But once the DevOps comes into play, we just have to share a container in the form of image which with all the developers or the different teams, so that they need not to worry about what kind of a version, what kind of a configuration or basic requirement you required for your application to run. So these were the basic things, okay, that we looked into our previous class. Let's just move forward. Okay, before container misunderstanding, a lot of things were happening. So what are we going to do today? You understood what are images, difference between the images and container? Can anyone
Yes,
explain?
Akash.
Okay, Vishnu, would you like to explain what is image and container, their differences? Vishnu, could you try? Any
Hello.
answer, any type of, yeah. Yes, you are audible.
Yeah, Akash.
So just tell me your understanding of image and container. Are
So,
you saying? Yeah.
yeah, I'm saying. So, you want the difference between, or
Yeah, what do you understand by image and container and how they are differ from each other?
so the image will be running through the container?
Image, nope. Container run through image, not image run through container. Okay.
Okay.
Until unless you do not have image, your container will not run.
Okay.
Yes, you won't be having container. That's Shreya, would you like to give it a try?
Yeah, so like a Docker image is nothing but the artifacts that are layered into an image, which can be moved from one place to another. Like you can tell from one operating system to another. But a container is the package where an application which has all the dependencies and the configurations that are needed to be run.
Good. Few things are here and there, but we'll make it a clear. Supriya, would you like to try?
Yes. So the Docker image is something a source code or libraries dependencies of an application or instructions of an application where we build a Docker, we create a Docker file, and then this can be stored into a distribution system. Where the container is nothing but, as you know, the running environment of an image, where we have an image, we have all the configuration or environment, I mean, the configurations and all, where we run the container, run the image. Yeah.
So, see, all of you are pretty much correct. Okay. So the thing is, image is basically a packaged layer of every configuration or the dependency required to run an application. So it's just an image, okay? You cannot run it directly on your machine. When it's totally packed form, okay, it's sealed. So the moment you take image into your local, okay, then you have to unpack it. And the moment you unpack it, it became a container. Okay, so whatever you run or do the operations, everything you do on your container, the moment it comes in your local. But as long as it is in the repository, it will remain in the form of image. That's why Docker images are not running. Okay, they are not in the running format, whereas Docker container are always in the running format. Okay, you can run and stop these operations. You can apply on containers. For image, you cannot apply any run stop type of type of commands on image. So image is just for transporting from one place to other place of your application, including all the dependencies. Whereas container always be in local. It cannot be transport from one repository to other repository like this. Okay, if you want to transport, convert into image and then transport it. So that's some basic of container and image. Be clear with this one. Okay, it's a basic questions you will be getting initial phase of your interview. Okay. Then we discuss about what is the difference between Docker and VM. So Docker is a fully application oriented. Okay, it will not change your kernel. For running your application, you need not to change your OS kernel. Whereas for VM, you have to change your kernel to run your application. If it is Linux based, you need to have a VM of Linux. Okay, but whereas in Docker, if even if your application is Linux, you need not to have a Linux on your OS kernel, the main OS. Okay, you just include in your Docker file, you just include your the basic Linux operating system, and it will be remain inside your applications. Okay. These are the benefits: size, speed, and compatibility you get with the Docker compared to VM. Okay. Now let's understand from here our today's class starts, which is understanding the Docker container architecture. Okay. Three things you need to remember: client, okay, where the commands being run, Docker host, which decides this Docker daemon inside this Docker host, decide which image to create, which image is being accessed, which image is being pulled, all the decision tasks. Kind of a brain of this Docker is this Docker daemon. And this registry is the storage area. Okay. So whatever the command we run, it goes first into this Docker daemon. Docker daemon then see in the local if this image present in the local. If it is present in the local, then it will make a container out of it if you have given the command for container. If it is not present in the in your Docker daemon local Docker host, then it will go to the Docker registry, which is basically the Docker hub, and from there it will extract this image and put it on your Docker host. That's how it's work. And this is the simple architecture compared to rest of the DevOps tool. Okay, you have one brain, you have one storage area, and you have the commands. Okay, all the commands goes through this brain. If not available in the body, it will extract from the registry, and if it is available in the body, it will do operation on those images or container. Any confusion in the architecture? Nope. All clear? Say yes or no.
No, Akash, it's clear.
Okay. Even if you have pretty much any confusion, just share. Okay, I'll be willing to go more deeper into this one. So in today's class, what we are going to do, we have an application on our system. Okay, let me just open it. See, I have two application, app 1, and another application is app 2. Okay, so this is a Python based application, and the first one is simple HTML, CSS, JavaScript. This is my own website that I made. So let me just show you how it looks like. I'll go to index.html and make it live. So it's basically a story website. Okay, if you want to read, you can click on read. If you want to write a story, you can write. Okay. Below you will get the kind of a story you want to. Suppose you want to see or read adventure story, you can see here. You can get more, you can like, read more. You will get more about on this story. So it was just a simple story kind of website. Okay, so what are we going to do? We are going to pack this one into a single image and push it into our Docker registry, which is Docker Hub. To push into the Docker Hub, you should have a Docker Hub login. Okay, you should have a this one account on your Docker Hub. Okay, and further, once you create your post, and you guys can share this image with anyone. Okay, let's see. Let's go. And another application that I'm having is a Python bit, which is a very simple one, just to print a message. So this is a Flask based. Python's one of the libraries Flask. Okay, so using this Flask, created a small Python application, which generally nothing but print a small message. Hello, this is a sample template Python application. Running where? Running on the port 5000. This is the port number. Okay. So if you want to run it on local, you just need this 5000 port number. Okay. Requirement is another file which contain this Flask. So if basically when you package this one, so you have to write a Docker file in such a way that it will download this module into your app, because it is the necessary. This library is required for your further task. If I run this one, so you see it is running on this port 5000. Control C. So a simple message. Hello, this is the message. Just do pretty print. Yeah. So we are going to convert into images of these two applications. Okay, I can do one also, but let's see if time allows, we'll do two. Okay, so to do that one, we need to understand one basic and the very important concept, and that is nothing but the Docker file. Okay, so Docker file is nothing but a simple instructions, okay, in the command format, which basically says how to convert your application into an image, and further it will be shared by everyone, and everyone can make a container out of it. So this image basically contain a lot of commands. So let's look few of the most important commands that it includes. Okay, so it starts from this. Okay, there are two things. Okay, if you are running any command, it could be a single line command. Okay, like this one. There it is. Run apt get update. This is for Ubuntu kind of, or Linux command. It could be a multiple command as well. Okay, run apt get update, apt install Python, or rm. So these are the two ways you can give your command. Okay, if it is a complex application, then you generally consider this one. If it is a simple application, then you can consider this one based on the kind of update or installation you required for your application. This is the run command. Then comes your copy and add. Okay, if you want to add something from your local into that repository, okay, I'll show you this one. This is the important one. So basically what we are doing, whatever in app.py, whatever the content we have, I want this to be put inside this Docker image. Okay, using this app, there get a app, you can consider app directory, and in that directory everything will be copied app.py into this one. If I'm using only dot, it means all your current directories, file, folder, everything will be copied to this directory, app directory. Okay. In a similar way, if you want to attach any URL, you can use add command as well. Okay. So this is just the extra one. Okay. Let's see the other command. Copy we have seen. Okay, working directory. So work directory means what is your current directory on which you are working. If you want to specify, you can. Okay, if you don't, it's completely fine. The important one is the expose command here. So if you want to run your application on a particular port, you need to mention them that on what port you are going to run this one. So here I'm using the expose command, which says that the application will be running on port 8000 or port 80. Forget this one, 443. It might be mistake. Any confusion so far? We'll look into the practical one as well. Okay,
No.
few of the things I have not added, which we will look into the complete Docker file. Okay. Then after we have this environment, okay, command env. If you want to create, generally use for the path one. If you want to create any path, then put in the environment variable. Then you use this environment command. If you have ever downloaded Java in your system, you must go into this environment variable, window plus R, run command. I can directly go from here. Edit system environment variable. So environment variable. So you can see these are the environment variable. This is the name and this is the path of your exe folder, exe file. So we generally do it for all the applications, okay, so that your system will recognize where is your exes, application exes. So that's the environment path we set, environment variable. The same you can do with the Docker file as well if it is required for your system. Then comes your CMD. CMD basically, if I want to run Python application, how will you run Python application in the terminal? You do Python app.py to run any Python application, a file. So in the same way, if you want to run it, you can use CMD in that way. Generally, we write in the shell format like this. Entry point always executed. Okay, this is the default one. Okay, always executed in the sense it cannot be overwritten easily. Okay, once you wrote the entry point, it will always execute this one. But this can be overwritten. If you write any further command after this, it will overwrite the previous one. But in case of entry point, if you write any further entry point, it will not overwrite the previous one. It will show you a conflict or error. Okay. So these are the two examples that we see for Python application. It always your Docker file starts from. You need to specify which OS you want to run on it. Okay. For example, in this web application, I want to run through this Apache server. Okay. So I have to get it this Apache server on my system. And if it is Python, I need to have Python in my system. So this one you will say download the Python. So first it will get the image of Python into your local. Okay, then the working directory, set the current working directory on which you are working. What do you want? Copy requirement.txt into this dot. Okay, so what I want, I'm just copying all the files of this dot into this requirement. Sorry, not that one, opposite one. All the requirement.txt into this dot. Okay. And then running a command, pip installed, no cache. This is not so important, cache one. Requirement.directory. It means whatever inside this directory, requirement.txt, you install it on my Python application. So for example, we are having Flask, right, inside this requirement.txt. So we will install it on my system. And then copy everything with everything. Means whatever present inside your current directory into that Docker directory. And then we are exposing it to port 5000 and running this command. So this will run your application. Or in a simple way, in a simple web application, so just Apache server, copy everything, okay, from your current directory into this Apache directory and expose it to port 80. Let's do it. It's too much of this one theory part. Let's open our application. This is, so remember your application is running from this index.html. So you need to have your Docker file in this root directory. Okay. If your index.html inside some folder, then that will be your root directory from where you are running your application. So since it is here, so I'm running, I will run create my Docker file here. Okay, so to create a Docker file, I have to go here. I'll simply take this one from this, and we will expose it to 480. Okay. If you want to run through Nginx, you can do it through Nginx as well. I'm not doing through Nginx. I'll remove it. Okay. This was the Nginx one. I'm not doing it. So I'm removing it. And then I'm exposing it. For comment, you can use this asterisk. Any confusion in these three? You require a Apache server in which you are copying all your current data. What is my current data? These all are my current data. Okay. So the dot means everything. Copy everything into which place? Into this htdocs. Okay. Once it get copied, then expose my application to port 80. Okay. So whosoever will download this, will get this image, the initial port will always be 80. You can do port binding. We looked into port binding in our previous class. We'll look at it here as well. Okay. So once you do it, let's save this one, Control S. And where do I want to? Yeah, it's the correct one. Docker file. No extension, okay? No .txt or nothing. Just Docker file. Save it. Let's just look. Where is our Docker file? See, it is docker.txt. It get remove that txt. It won't work otherwise. It should be only Docker file. Yes. Any confusion till here? Anyone?
No, Akash.
No, Akash.
Okay. Great. Now, what are we going to do? Let's check Docker PS. Do we have any container? No, we don't have any container. Docker PS, what is the meaning of Docker PS? And if I write PS-A,
All
what is the
the
difference between these two? Yeah,
only
please.
running containers will be showed in PS.
Great. And Docker PS-A?
All the containers which are stopped
Correct.
also.
Correct. So what I'm going to do, I don't have any container so far. Okay. I don't have to do with any container. This is just for revision. Now what I want to build. So Docker build. Okay. Now what I'm building my application. Okay. Docker build -t. All this command I have written into a single file. Okay. I'll just take you with that one too, so that it will be easy to verify everything. Okay. So troubleshooting Docker Hub, volume, network, data include, build and all, code binding, container, images. Yeah, here it is. So for creating image, this is for building image. Okay. Docker build -t. -t means tag. Tag of your what? What is the name of your application you want to keep? So before keeping the application name, you need to provide your username. Okay. What's username? Which username? This username. AVA29, the Docker registry username. Okay. And then after, what kind of a name you want to give? Suppose it's a web application. Okay. Web application. And then after, if you want to associate with any other tag and all, you can do it. Any versions, if you want to define, just colon and define the any tag, specific tag. But for now, I'm just keeping it simple. And then this dot. This dot means you are building everything in your present working directory into the Docker image, and press enter. Okay. So it gives us an error, invalid reference. Let's just check with the command that we have entered. Version we need to provide. Generally, what happens if you do not provide version, it takes the latest one, but suppose 2.0. Session.
Image name is issue here, Akash. No need to mention, I guess. When we push, we can change the image name. Yeah.
Is it the backslash? Let me just confirm it. No, it's not the backslash.
Repository must be in lowercase web application. WA.
No, so far I know it shouldn't be
That
that
is
one.
the error here. A repository must be in lowercase.
Our name is just check. Docker build -p image name version and then dot. That's correct. That is not taking this. Let's remove the username.
And use the lowercase. That would be better.
Okay, let's use the lowercase. So it is okay. That's something I have tried whatever it used to take. I don't know. Yeah, pretty good. Thank you. So once we build our image, then let's check this one. Docker run -p, and we are running on port 80, so we can use 80:80. And since we are having this application on our local, we'll take it. So this port has already been taken. Let's check other port. So now it is running 8030. So I'll just go here, localhost 8030. So this is the testing part. It means your application has currently been packed perfectly and it is running on the port 8030. What is this? Is it in attach mode or detach mode?
It's in the attach mode.
Yeah, if you run in a detach mode, you won't finding all this crap. Okay. So I'll just do Control C. Fine. And then we need to push Docker push. Now, what it requires, first you have to do Docker login. Login successful. Check this. Push name. What was the name of our application? Web apply test. Will take a couple of time. Okay, but it says that the recognized.
I think the folder name needs to be mentioned.
Which folder name?
There in the you had given the username, right? To where
Yeah,
you need
yes.
to. Yeah. So
Generally, what
this image
happens?
name should match to the image name in the Docker Hub. I think so.
No, so far, if it is login successful, wait, Docker logout, Docker login. Let's do again. Okay, Docker login with a different account, then Docker logout, followed by Docker login. Okay, Docker logout. And then Docker login. Now it is giving a certain URL. Copy this one. And one time code you need to provide, which you'll be getting here. And from set. Now we have to wait for the authentication here. Docker push. Or let's give the 829. The push referred tag does not exist, of course. Right is given. Push access denied repository does not exist. May require authorization. Server message insufficient scope. Should failed. I have pushed a lot of images, but why it is showing the error in that case? Hmm. It's web application. Mhm. Hmm. So the push denied repository does not exist. Authorization space. Such Docker hub. Okay, this error can estimate the several possible issues. Authorization we did given Docker login. We did the login part where you're doing the push. Check stack flow sees. Oops. I need to look into this one. Okay, why the issue is coming. It generally does not come. Some kind of authentication authorization is required. Okay, I'll look into this one. Okay, till then, whatever we did so far, just practice from your end. We switch to other topic. I don't know why it is coming. Totally baffled. Images we have.
Akash, can you create a repository in the Docker hub? There is an option now, create new repository with the name
Yeah,
of the
there is.
and then try create an image with the same name. Create the repository with the same name, image name, web application.
Sure.
Yeah,
It'll
great.
be available. It's public, everything is good.
Now try to push.
Let's try this too. It's not, it's trying to reach first the Docker repository, okay, Docker hub, and it is getting denied at that moment. It's not allowing to enter. Server
Okay.
insufficient scope. So I'll take a look, not to worry. Okay, nothing is different. Push command, did I mention here? Docker run paste. Scope finding. Pull, publish, login, search. Push command I have not entered. But that's okay, no worries. Okay, it's some kind of internal issues, and that's okay. Issues should come. Okay, if everything goes smoothly, we won't be getting into it. Okay, like the one thing of case sensitive, your Docker image name should be case sensitive. Okay, it should be in the smaller case. Let this be. I'll cover this in our next class. Let's focus to our next topic. You not to worry. And this is kind of one of the advanced topic that we look into this. Generally, it is not asked for the beginner purpose. Yeah, only if you have 3-4 years. That's why I included this one. So Docker volume. Okay. It basically says that when you create a one container and you have several data on that container. Now, what do you want? You want to share that container with the other container. Same data you want to share with other container. How will you do that one? In that terms, this picture comes into play, Docker volume. So with this one, Docker volume are preferred mechanism for persisting data generated by and used by Docker container. So whatever the data you use in this Docker container can be utilized or can be used by other container as well. So in general, every container is independent to one another, but in Docker volume, you have to have uh, a container. You can create a container and the same data you can have in the other container as well. So let's go and quickly look. If I do Docker volume ls, it will show you the current volume available in your system. So far, I don't have any volume in my system. And to confirm that one, I can go here. I can check in the volume section. I don't have any volume. That's okay. Let's create a volume. Docker create volume. Let it be my volume. I'm able to find the create volume. Always Docker comes with volume. Okay. Docker volume, and then you write all your command. So we created our volume 1. Okay. If you want to check, do docker ls and you can check. You have one volume. So this volume, all the datas that we will create in the further class, all the datas we will store in this volume. Okay, let's go and do it. I'll just come here. So we have to take an image in which we can create some data. So let's take Jenkins for that one. Let's go to the documentation. Okay, so basically, what is the difference between Docker run and Docker pull? Anyone? Shreya?
So Docker pull is only you're getting the image, whereas Docker run is you will pull and run the image as well.
Absolutely correct. Okay. So we are going to pull the image, run it. Okay. So along with pulling, we are going to run on our port as well. So what I'm going to do, I'll copy this one. I'll come here. Okay. Certain things I do not require from here. For example, let's take JDK 21. And this one is for on failure, it will restart, which is I don't want to restart right now. Okay. The very first port is the web port and the second port is your API port. Okay. Let's give it a name as well. Docker run hyphen name. My Jenkins. Okay. My Jenkins 1. So the container name is going to be my Jenkins 1, which will be running on port 8080. And web API port will be 50,000. And this is going to be the image name. Okay. Perfect. Port 8080 might not run because some other application might have acquired this one. Let's check it. I'll run it. In local, it is not finding. So it is going to pull the image from the repository. Okay. But it shows error as well. What is the error? It pulled the image, but it is unable to run the image on this expose port 8080. Okay. So what do we need to do? We need to choose another port. So we can do so for now we have two images. Okay. The web application one and the Jenkins one. Okay. And the Docker PS. No, any container is running. Docker PS -a. Okay, so we have couple of images, couple of container, two container for web application, the previous one. Okay. Another container is for our this one. The image that we just got extracted. So what I'm going to do, Docker run -p. Okay. On what port? Let's try port 8090 on 8080 and -p 40,000 colon 50,000. Okay. Remember, from this image, we are going to run it. Okay. So we need to provide the image name. If I just write this one, what will happen? Any idea?
Jenkins without JDK runs.
So you will get another Jenkins version, the latest version of Jenkins. Okay. So another image will be picked out, which will be the latest one, and this JDK version will go. I'm going to go with the latest one so that every time I don't have to write this tag.
Akash, first
Mhm.
port is the server 8019 server port and 8080 is a container port, right?
This is the container port and this is the
Yeah,
host
this
port.
is a server. Yeah, okay, host port. What
Yeah.
about this 4000, 5000?
So this is the
40,000.
API one. Okay. It doesn't comes with every application. For Jenkins, you have to run their a web API as well. So
Okay,
you have to run their API as well on a certain port.
okay.
Okay. Let's run. So our application is running. We got this one. I'll just copy. Keep it somewhere. There. So we run our application on what? 8090. Okay. Localhost 8090. What is this? Did we run out previous? How is this happening? Eighty ninety. Why StoryNap is running on this one? We can go to our Docker one. Let's go and check the images. So for now, I'm not using this web application. I'll delete this one. And this cannot be due and done because it's 80 30 80. Anything more? This one is currently running. Hmm. So we got it generally happens if previously someone was using, but there is two thing. Okay, I don't know why it happens. If other application is already using this port 8090, you won't be able to run this this Jenkins on this port 8090. But it allowed us. Okay, and why it allowed us, we will look after. There might be some network. There's a known as a Docker network, because of which it happens. So for now, what was our key? This one. For quick purpose, I'm not going to install anything. I'll just go with the default configuration. Install it. Escape and continue as admin. Localhost 8090 will be using. Save and finish. Start using Jenkins. I'll create one job. Paste that project. And a small data over here. Hello. Mm, one mistake we did. Okay. The mistake is while running Jenkins, if you do not, if you want to prefer this volume part, okay, then you need to use that volume while running the Jenkins. Okay. So in that case, just allow me some time. I hope you guys are not in hurry. Can I take half an hour? more. Is that okay? Hello.
Yes, Akash. Okay.
Rest 2 are okay.
Yeah, okay, Akash. But actually, I have another meeting in some time, so
Okay, I'll try to do quick as much.
yeah,
So
okay.
we need this volume, okay? That's why I forgot to add this volume. We'll do from the starting. Docker run is clear, okay? Running in the detached mode. Right now I don't want in detached mode. -v is the volume. What was the name of our volume? My vol, right? This was our name. Then let's choose, I'll choose 8010. 40,000. Yeah. And I'm going to take the latest one. Oh, just check once. Docker run name we have given, volume. Yeah, FNV port number we have given. So what will happen, whatever the job we will create in this Jenkins, every job is going to be running on the Jenkins wall. Some exceptions. Why I did not get that key, the key that we wanted. The container is not running. Push this. The container name has been given is already used. What it is. I'm doing it little faster, okay? If you get confusion in any of this, oops. I wanted to skip this one. Any confusion in the command that I run here? Docker run is clear. Hyphen name is the name of your container. Hyphen v is the volume. Okay, what volume is the in this volume? Whatever the job you will create will get stored over here. Okay, and these two are the port number of our Jenkins and the Jenkins API, and this is the name of our image. Come on, okay. Let's skip for now. Localhost finish Jenkins new item. And we create a job. So let's run it once. Okay, it runs successfully. Now I'm going to detach it. Control C. I'm going to use the same image, okay? But the thing is, I'm going to create another container. It will create another container. Volume will remain the same. I'm going to host this container on port 8020, okay? And this one API on 60,000. Press enter. It will create independent another container, okay? This container is independent, previous one is independent. There is no relation. But the thing is, we created on the same volume. So what I'm going to do, we use the port number 8020, right? Localhost 8020. In this case, they are not asking me to use that pin and all. They are just directly asking me to give the username and password. Why? Because on the same volume, we are going to share the data. So what I'm going to do, this is our password. Okay, since I use the default one, admin, and the previous container password I'm going to give here. So from our logic, this job should be here and it is here. Okay, so in this case, we are using the volume sharing task. So one volume we shared with the other container as well. So if I go, I'll show you here. We are having two containers with the name Jenkins1 and Jenkins2. Okay, the task we created on Jenkins1 is now replicated to Jenkins2 as well. Forget the spelling. Okay. Any confusion?
No, Akash.
Okay, thank you. Because this one I did pretty quickly, so you might be having some. You can even do it on your local. So if I do, if you don't want the things on the volume that you created, you can just do it like this. Create Jenkins3 instead of my wall. I can provide the location of my local folder. Suppose here I create one folder, test Jenkins. Copy this one, go here. I'll paste it here. And the port number you have to change. It should be 8030, let it be. Now 30,000 and press enter. So the moment I do it, it will search in my local. This is the test Jenkins, and it start creating all the files which are necessary to run the Jenkins. Along with that, it will contain the, see, all it is creating secret files and everything, whatever inside that volume. So you can do in multiple container sharing as well as you can do in the local container, local storage sharing as well. Okay, this was the most asked question in case of volume sharing. Any confusion? So we shared all the data in our local volume as well. Let's see, I'll just stop the container. Any questions? So sorry, it went out of time. So we saw Docker volume create, Docker volume ls. Okay. RM is for removing the volume. Inspect if you want to inspect more depth into it. And prawn means if there are some volume which are unused, this prawn will remove that volume, unused volume. If couple of days you have not used that volume, it will remove it. Okay. So this is all about Docker volume. Shreya, Supriya, Vishnu, any confusion, any question?
No, Akash.
No,
Okay.
Akash.
So what is the use of this one? Decoupling container from the storage. I mean, not dependency upon the one container shouldn't be there. Okay, sharing volume among the different containers. Then attach the volume to container that we have seen. On deleting one volume does not delete the other. If I delete the one container, it will not delete the other one. So your volume will be secured and it will be remain undeleted. A very quick one we'll see in the networking. Okay. So if I go here, if I do Docker network, so it will show you what are the networks available in your system. Okay. Connect to a network, Docker connect. If you want to connect with a network, use Docker connect. Okay. If you want to, there are a lot of definition. You can use any of this Docker inspect network. What is this one? I'll just tell you. Mm, Here I have mentioned list all Docker ls. It will show you all the Docker network available in your system. So there's some network known as bridge, host. Okay, you can create your own network as well. Mongo network I created long back. Okay, which is a bridge network, and none. Means by default this network is available. Even bridge is by default. So what does it means? Suppose there are two hosts, host 1 and host 2, okay, in which both the hosts contain two containers, okay. Host 1 is containing one container, host 2 is containing two container. Now there is a one user who want to access one container on uh this one port 1337, okay. But on the same port, if he try to access the other container, he will get the error that we got. That one port every time if every container was requiring a new port. So this was the problem that we were facing. In case of Docker network, okay, there are multiple type of Docker network in which one of the most famous and by default you will get is the bridge network. So what is the benefit of bridge network? It will create a bridge between these two container, okay. And the thing is you can have the same port number. What it will change is the IP address, okay, so that the data can easily be shared and a network can be established between the two container. Here you cannot establish the network if both are independent to one another, but here you can establish a network. So this same bridge connection, network connection established, okay. So now this user, what it can do, it can connect with this one, okay, 1337, same port number, okay. He can again, in the bridge, you can share for sharing the data, port number will be the same. But the moment you come outside, he has to connect with a different port number. So what he did, the same, both the container we are sharing, container port was 1337, you can check, but the host port is different. You need to have a different host port, but the container port can be the same one. Okay, so this is the benefit of having a single bridge where the communication can easily be happen and both the container can have the same port for internal network connection. So this is about network. There are more deeper. It is a very advanced topic. Okay, I haven't gone with the practical one, but in the later classes, if I get the time, I'll look into that one. I'll just stop, and if you have any question, please ask.